welcome Tim, welcome Bill, welcome Jürgen, welcome Luan, and the others that will still come. I suppose that this is the presentation of Tim. You already shared it. Fantastic. To all of you who are in right now, and I'll write this in the chat once others are coming in, what I hope is when you are presenting, you open your mic, all the others mute themselves, you adjust your name. I will do this right now because I'm here with Thomas Schindler's account, so that you know who I am and what I stand for. Perhaps you may even add a company so that it's easier to know who we are. And yeah, that is basically it. I want to welcome first Tim, who's presenting here for our first session. Tim is an entrepreneur, and he's also a researcher and a product architect. And the question is, how do we work with data? How trustworthy is data, and how can we make it trustworthy? I don't know. I'm very excited to learn a bit more. Or perhaps you leave us completely confused because this VUCA world is not manageable anymore. We will see. Thank you for being here.
Thank you very much. I'm very happy to be here. Thank you, Kai. And I think because the session is recorded, I guess most of the people who are interested in looking at it will look at it after the fact. So we just get started, I would say, even if it's only 5 people right now. It will hopefully give us more time for having an interesting discussion in the end. All right, so let's get right into it. I think that we are all impacted by the role of verified data in the fake news world, in the sense that we don't have verified data. And what I would like to present to you today is a process to digitally publish content in a way that we can reestablish trust with each other by verifying data. So I want to present you also a way how we can use verifiable data to increase and measure impact of our actions. And I think this is really important, especially if we speak about impact investment, if we speak about change, and if we want to quantify change without dumbing it down into a number in an account. And with the solution we are building, and this is an open source solution, so everything you see today here is freely shared and should be used and assimilated and built into other products. So we really welcome that. What we can do with this architecture is we can increase organizational trust by giving data verifiability. And with that, we can measure impact. As I said before, we can produce digital evidence to create accountability again. And we are able to build a strong foundation of trustworthy news. And how this is done? Well, you will learn if you stay sharp in this presentation. And I hope that I can tell you everything I know about it, which is required for you to navigate and also to produce verified data.
Cool. One question, Tim. Would you be willing to share your presentation? Of course, this is recorded here, but share your presentation directly with those that that want to look into it after?
Absolutely happy to do that.
Great.
For sure.
Thanks.
So the way how I describe it right now is like we're kind of lost in the digital space because there is no way to know really what's going on anymore. If you go, for example, on YouTube, there are thumbnails which change all the time. You have situation, you go to a website and then it gets edited without you recognizing it. If you go to a news page, there is a possibility that your content on that on that news article might be changed multiple times, or that the author might change without you recognizing it, or that the timestamp of the publishing changes. And this is also used in malicious contexts to, for example, claim that you have editorial rights and tell somebody else to put content offline, for example, another ISP, because you claim that you have published the content you want to see it removed from an ISP before, for example, a blogger, right? So there's a lot of malicious behavior happening in this direction, and there's very little opportunity for us to trust. But what happens if we put data in a fixed position in time and space? And we know that from sailing the seas, like our ancestors know it actually, we might know that there is a North Star, which you might see in the sky here as well, as the extension of the small clipper, which you see in the picture. And this is a way how we can navigate the ocean, and how our ancestors did it for a long time. It's because they have fixed points to navigate with. And this is what we reproduce with verified data by putting it into time and space. So we give it a unique name. And when I say unique name, I mean really unique name. This means like it's impossible to guess that name. We take the chaos of the universe and we put it into technology in a way that we get a really unique name. And we ensure that we have cryptographic signed signatures. For that, we use wallets. Those wallets are tools sometimes which look like this, you know, like a USB key, which is outside of your computer. So if your computer gets compromised, you still hold the key to your kingdom. But they are also available in other forms in your browser, and we will see later how they look like. And what we do is we put timestamps on things. And timestamps are incredibly important. And the best cryptographic clocks we have today are so-called blockchains. And they're really good cryptographic clocks. And we use them to ensure that there is a proof of existence. So in a summary, we create the stars we can navigate on. We put data in a structure that it becomes fixed in time and space, and we can reliably refer to it. So let's speak about the agenda. What I would like to go through with you today. And this is the historical context first about institutions and truth, the problem we are tackling, the software we are building, the goal we accomplish with it, and the product philosophy we use to accomplish this goal. In the end, you will see a prototype presentation of the software, how it is in the current state. And I need to repeat that this is a prototype. So what you will see is not a final product. But we are getting there, that we start with the first pilot studies, and we have the first interested parties as well. Let's speak about institutions and truth. In a time before our time, so when we still were tribal with each other, data management looked very different than it looks today. So we go many, many years back into a time where we lived in tribes, like villages, tribes. And when there was something important happening, we would come together and we would share what was important to us on the fire. For example, we would create a new family, and then we would have a ritual to acknowledge this new bond. Or there would be a new baby coming to the community. And then we would welcome this new citizen in that tribe with a ritual. And the same is true if somebody dies. So there would be some form of ritual to say goodbye to a member of a community. And that all would happen around the fire, and it would be ritualistic, so to give it extra meaning, that everybody can remember it and everybody is witness of that event. And what this does is it creates symmetry in the experiences of the people. And on the next day, if you speak about this event, everybody would have a sufficient similar experience to say that this is true. So truth is something which arises as a social consensus between people. And in this case, they all have witnessed something, so they say it's true. There was a change, and this was not okay anymore for declaration of truth. And we go forward in time to a time where this was institutionalized. So a time where the church was the state in Europe, for example. And this is just an example. I'm sure there are other religions we could take, others than the Christian church as well. But we speak about the Christian church as an institution here. And they brought the book of truth. So what is true is in the scripture, but also what is true is in their book, in their parish books. They call it in Great Britain, for example. This means now when something is going to be witnessed, everybody would be asked to come into the church and to witness the event. For example, somebody marrying, they would be asked to come into the church. And then the authority would also put it into the book to write, okay, the priest would write in, for example, Eva and Adam, they're marrying, and they get a marriage certificate. For the church to do that in an effective way, they obviously have the book in the church itself, but for that they need a reference of time. So they have the Gregorian calendar to be able to reference time and to put their ledger, the book they are holding, into the context of time. And also what we have in the churches is usually clocks in the top. So they were also the ones which like gave time into the village. And they would hand out a certificate, which should be a forge proof. So it should be very hard to forge it as a confirmation that an event has happened, which is a copy of the book of truth they hold within the organization, in the institution. And this is true for new members of the community. So when somebody new is born, they would baptize it in the church, and they would do the same thing. They would add an entry into their book, and they would issue a certificate. And this is true also for the certificate of death. And we know that graveyards, for example, in villages were often next to churches for the same reason. So the church has now incorporated the role of being the witness authority and having the book about it and issuing the certificates for it. And they were pretty much the land registry and the population registry in the early days. And they always would ensure that the time, the location, and the author would be entangled in their records. And with that, they created institutions as symmetry preserving machines. What does it mean? It means that what is true within the book of the organization would be duplicated by handing out receipts which are hard to forge. And if I have marriage, for example, in Italy, I could travel to Germany or to France and bring my certificate of marriage, and the church there would accept it if the churches trust each other. And this is just an early version of it. What we saw later is the scaling up of institutions as symmetry preserving machines in economics. So there's Luca Pacioli and double entry bookkeeping. So this is a protocol to create data symmetry between organizations, because now we have one organization trading with another organization, creating an invoice, which is a receipt of account balance change, which is then handed over to the other organization, which puts it into the entrance of their books. So what they do is two organizations synchronize each other with receipts of their accounts. So they become like, this creates a network of accounting and allowed for international trade at a scale it has never been seen before. It's the foundation for our globalism, for our ability to trade globally. If we take that as an example, think about passports. Are passports receipts? They are. They are certificates or receipts out of the book of entries. Who is allowed to travel internationally? In this case, it's the US passport, which means that everybody who is in the list, in the registry, in the book, who is allowed and authorized to travel internationally would get a receipt, and the receipt would be the passport. And the passport is very hard to fake. So the transaction security of the passport determines the trustworthiness of the institution. Another example is, for example, university degree, which is nothing else than a book of who has actually accomplished like successfully overcome a certain challenge. And if they have overcome a certain challenge, have proven that they know something, then they would be added to the book of the people which have accomplished the challenge and get a certificate of it, which is their university degree. And now we look at money. It's the same thing. It's nothing else than a tradable receipt of account balance. And there is a very limited authority which is allowed to create this money and which holds the balance over those accounts. But in general, it's just a receipt for another book of truth which holds the balance. And we can think the same way about, for example, newspaper, right? So especially in the First World War, for example, newspaper was the means to share information. Sharing informations from the truth the newspaper had, like the narrative they would hold, and then they would create a lot of copies of that narrative. And what this is, the newspaper itself is the receipt, and they would be this symmetry preserving machine for a lot of other people being involved. And the higher the symmetry between the participants, the higher the ability for collaboration is as well. And we could think the same way about media, that these are symmetry machines which try to create data symmetry between the people which consume content. But what does it mean if we put it in the context of fake news? Well, what we see is, with the current problem we are having, is that it became very, very cheap to fake data, fake certificates. For example, you look at this vaccination certificate of the WHO. And what this is institutional failure, because one of their main responsibilities as an institution is keeping the authority over the book. And now the book is in question. And it is very important to keep the transaction security of the receipt. But now the receipt can be easily manipulated. And this corrodes the trust in the institution. And we're not only seeing this with like the WHO vaccination certificates, we also see that with a lot of other certificates, like university degrees and. So our goal is to build verification systems, open protocols and architectures for data verification, so that we can reestablish trust in the way how we relate together in society. Don't be shocked. This is just a screenshot of like the work we're putting into creating an open standard. So at the end of our journey of our work, we hope to establish an international standard for verification, which will be established by the IEEE. So that this is something every human can use without being even aware of it, like the SSL certificate. But for that, we need to first show that it's working, and we need to run sufficient pilots to get the backing and support we need. To ensure that we do that as easy as possible, we use international standards which are already established. So don't get shocked here. This is just saying that we are using 2 established open standards already to build our verification machine. So this is a SHA-3512 hashing function, which is a NIST standard, which is already a standard in the computer space. And the same is for public-private key encryption. We're using a standard which is well established. We are building on open standards, an open source technology. Our product philosophy is, well, to explain that, I will explain you the short iteration how we connected keys and value. Every time when something changed in technology, we had new keys for new identities to access value. And you will see that this is very easy to understand if we look, for example, at the old way to access value, for example, a normal key, which would usually open a treasure or a vault. And now we're using a vault with a lot of gold in here. So imagine you would have a key, which is your ability to access a certain value. In this way, a physical value, in this example, gold. But this has evolved over time. So there are other keys which we use to access value, which is another form of vault. And in this case, it's already digital and it's money. But this has evolved even further with the evolution of cryptocurrencies. So today we have biometrics, we use our phones, we use passports to access our value, which now could be on our phone in the form of, for example, cryptocurrencies. And this is now our new key. Our new key is now our secret, which we hold, plus our biometrics in many cases. But what is the new key for data? I mean, most people know that data now has become the most valuable commodity in the international markets. Like, data will be the thing also for the next generations to come. And it is really the question, how do we participate in the data economy? How do we own our own data? How do we access data? And what keys do we use for it? So we use the same keys which are used to manage crypto assets today. So this billions which are in this blockchain space has evolved a very well established standard for wallets. We're using the same wallets to give access to data and to manage data. So I show you once more. This is this key for those people which have a higher security need. They can use those external keys which will not get compromised even if the computer gets compromised. For other people, I show you the little fox in the left corner here. This is MetaMask. This is the MetaMask Fox, which is a browser extension which holds your secrets to be able to interact with data and to sign and represent your identity. So now I would like to take you in a space of imagination. So imagine for a moment that there is a space in the digital world which is only owned by you, which is omnipresent and trustworthy by default. We would like to give every human being this place in the digital space without being afraid that somebody else might control that data, abuse that data, however you want to think about it. Imagine a container which holds your knowledge and is managed through your digital identity. This is exactly what we built and what we call personal knowledge containers. Those personal knowledge containers can hold anything you can think about, which is yours. For example, the backup of your phone data, your contacts, your intellectual property and your contributions, your medical records, or other data which is yours. But for this concept to work, we cannot trust empty promises. We need to design an architecture which starts with the control of the user first. So this means those containers which we provide to everybody, they can be installed on your local machine, on your computer. And you see there's the fox on the left side again. The fox is the account, is the way how you open your container. This is how you authenticate against your container to open it up and to decide what you want to do with it. On the bottom, you see that in this container is much more than just zeros and ones. We have different forms of data. For example, in the middle, you see a page. A page is what you look at. At this very moment, you're looking at Zoom. And this is a window into this presentation. On the one side, you're looking at a file, which is this presentation because I'm not changing it. It's just a stored presentation on my computer or in the cloud. On the other side, you're looking at the service, which is seeing me speaking and moving my hands. It's a continuous change, which is provided by the Zoom service. So on one side, we have the files, which is like the archive, which is static and not changing. And on the other side, we have the services, which are like our workbenches, our things, how we change things, how we allow files to be changed. And in the middle is the way how we see it. So in computer science, we can express pretty much everything we want to do with files, pages, and services. And those tools we put into this container. So this means on the left side, you see Git, which is one of the most successful file governance tools allowing collaboration for over 60 million people worldwide, with a platform which is called GitHub right now, which uses Git as a file management tool. So it's a distributed governance tool for files, right? And in the middle, we see Mediawiki. This is the technology used for one of the biggest websites in this world, which is Wikipedia, and which allows collaboration for over 400 million people. And on the right side, you see a service governance tool, which is Docker and Docker Hub, which is used to govern services at scale. So we see a tremendous amount of collaboration through those governance tools. And we take the degree of maturity we see with like the development of those tools and put them together to give every single human being the capability of governing their own data. And for that, we always start with a private container. So this means you install your private container on your machine, and you have the key to it through your wallet, through your identity. And if you choose to share something with somebody, you create a usage contract with somebody. And the usage contract is based on verified data too, so it becomes unforgeable if you use PKC to create it. But you can also decide to share content of your container publicly if you want. So now we are going in the direction of the first reference implementation. So it's getting a little bit more technical, but please stay with me and I will try to rehearse it on a very easy to understand level. It's lightweight technical content, I hope. Let's focus on each step we are going through. So data accounting, we do it with a Mediawiki extension. We use Mediawiki, which is the software of Wikipedia, and we have written an extension which is open source to extend the functionality of Wikipedia, which means Wikipedia would be able to implement this if they wanted to into Wikipedia itself. Keep that as an example for creating an organizational knowledge network, because when you use a personal knowledge container and you interact with each other through importing and exporting data sets, you can create a network of transactions with each other. And this can create a network of trust. So while we speak about those containers as being really closed down, we have automated the process of verification. So it's very easy to take something out and send it into another container. Let's understand data accounting. What we really do is we account for data, which means we ensure that there is no unaccountable data. Which means like we know where it's coming from, we know its history, we know who has changed it, and we know when it happened. And what we do is we turn a page file into a content blockchain. What does this mean? It means that a file which has revisions, and I'm sure you all know that from, for example, editing a Word document, and then you look into the revision or history, is nothing else than the composition of each and every revision. This looks very, very similar to what we see in blockchains. Like we have a block and then there's a new block and they somehow are interlinked with each other. But in a blockchain, it's cryptographically entangled. They become inseparable. And we use the same principle to turn this file into a content blockchain by making it entangled. So in this case, we use a cryptographic signature, which we add to the first revision of the page. Now we create a second page, which is entangling, like it becomes cryptographically entangled, inseparable from the first version. And it now contains the first revision and the signature, so the history of the file. And then we add another one, like we add another signature, we add a timestamp. And again, we make them inseparable from each other through cryptographic processes and build on top of it. And we go on and can extend that as long as we want. If we compare what are the benefits of blockchain versus what are the benefits of using personal knowledge containers, there are some benefits of blockchain which we want to keep. For example, that everybody can use it, which is permissionless. There's another aspect, which is this is public. So you don't really want to store private data on a blockchain because like everybody could see it, right? There's highest transaction security. This is why people use blockchain, and this is the reason why it can hold value of billions. We have a continuous service. Blockchains are just available. They keep running and keep running and keep running in the way they are organized. But they're expensive. If you want to have millions or billions of transactions, it's just unaffordable. So private content blockchains, which we create in our personal knowledge containers, they are also permissionless because everybody can do it. You can just download it and install it, but they are by default private, which means by default, your knowledge will be a secret. Like it's only yours. Nobody will see it if you're not sharing it. But we can achieve the same transaction security by allowing the fingerprint of your domain to be witnessed. So we have a cryptographic process to allow, and we have the same transaction security as in blockchains. And we can ensure that you have continuous services by having sufficient backups of your PKCs running. And it's cheap. So you can run it and build hundreds of pages. You don't even pay anything for it. And then you can collect them together and scale it up to timestamp them on a blockchain to have the highest transaction security you're seeking. The cryptographic foundation for that is fingerprints. So this is a very long key, and you don't need to remember it. All this says is we are having a way how we can take something like a human being and generate a fingerprint, which is representing the human being, but is not the human being. So I can compare my fingerprint with my thumb and see, okay, they are matching, they're the same thing. but you cannot reconstruct me as a human being from that fingerprint. So if we take a fingerprint of data and we publish or share it, it's not possible to reconstruct the data from it. So we keep it private. And this is what we do. So we take the page content, for example, our news or our digital created paper, the metadata of it, when was it created, by whom was it created, and so on, our digital signature, and the moment where we digitally timestamp that, we put them all into those fingerprints, which are in the end only one fingerprint. We call them the page verification hashes. And they represent the revision of the page. What we will look at now is how does this look like if two personal knowledge containers interact with each other. So now we are thinking about collaboration. We want to have it very secure on the one side, and we showed already what approach we are taking for it. Now it's really important to understand how much time we save people being involved to be able to trust data. And the way how we do that is we first create a new file, which is the genesis of a new content blockchain in a personal knowledge container. And we assign that file to attribute it to an account. We timestamp it to prove its existence. And then we send this to a digital witness network. This is a fully automated process, which allows you to prove that this has existed. We entangle it with a new revision. So this makes it inseparable. At this moment where we create a new revision, it's impossible to remove the signature or the timestamp or change something in the content of the page without breaking the verification. And then we take the whole thing and we make it mobile. So it's really easy to just shoot it to somebody over. So I can send it to anybody of you. It's a small file which holds all the data. And in the moment where it's arriving in our new domain, in the second domain of the second person, it's automatically verified. So it takes like a couple of seconds and then it turns green. The page turns green. You see that in the browser. And there is no additional investment from your side to manually verify anything. The extension and the software will automatically do it. And then when you trust the file, because you have seen, okay, it's verified, you can sign it again. You can extend it with your own timestamps, your own content. You create your own revision of that page before sending it back to the person who sent it first to you. And this could be a little bit, okay, you could say, okay, that's abstract, but really important. Like we had an exchange of trusted data, verified data between two domains, automatically verified, saving a lot of work and time to ensure that you can trust that data. And what could have happened in the real world is a couple of scenarios I would like to share with you. So this was an abstract process, but now I would like to look with you into specific examples what this could have been. For example, Jack and Jill both have their personal knowledge containers and use it for collaboration to exchange verified data. Jack wants to document a court hearing. So he's sitting in a court, he's documenting a court hearing, and his job is to hand it over to Jill after the documentation to get it confirmed by Jill. And Jill is using also the personal knowledge container to look at the file after Jack has created it and confirms it with her digital signature after verifying it, adding maybe something to it as well, and then sending it back to Jack and to her organization. She's working for the court. The court has now a digital evidence of the court hearing, which is documented and witnessed by a distributed blockchain. It is impossible to change this file without compromising its security. So there is a reliable piece of digital evidence of the court hearing. Another example, what could have taken place, is Bill and Ted both use personal knowledge containers to exchange verified data with each other and to automatically verify it. And Bill is representing an impact organization which is seeking investment. He has worked before with Ted and wants to narrow down now the final agreement for the investment. And he is doing that by sending Ted the contract for the investment. Ted confirms the contract and is countersigning the document. And then both organizations, after sharing a copy with their organization beyond their PKCs, now hold a trustworthy, unchangeable digital receipt of what contract has been signed. and I want to repeat it again, this contract cannot be changed after the fact. There is the possibility to add something to it, but you cannot change its history. So there is a digital evidence of the contract, which is now available for both organizations. And the last example I would like to share with you before we go and look at the actual software is a group of researchers. Imagine there's a university, there are like 4 brilliant researchers, and they're working together, and they have come across a world-changing invention, a discovery. And they use their personal knowledge containers to exchange data, research data, and to also compile their paper and to sign it and co-review it. And what they do is, after they have completed their paper with their discovery, they publish it by putting the fingerprint of the data set onto the automated witness network. And what they now hold, and this is very, very, very powerful, is a blind proof of the existence of their paper even before publishing it. Which means if somebody steals their paper and says, I'm the author, they can say, no, 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 you aren't. There's a mathematically provable verification mechanism which shows that our paper had already existed and that we have created it. What this allows for impact investment, for any organization, for journalism, is that we can create a network of trustworthy data points. We can create a personal, a network of trust with personal knowledge containers which are interacting with each other. Let's look into it. Enough of talk, enough of, say, theory. What I want to show you is an example of what we can do to create educational certificates. This is just one example. You could create any certificate, any contract. But what we all had when we were young were school certificates. So I will walk you through the process of creating a verified school certificate. And for that, I'm going into my domain. You see that this is the domain I'm in right now. This is a Mediawiki instance. And on the upper right corner, you see the DA. So this is our extension, which has automatically detected that this is a page which has integrity, which means it's automatically verifying that the page has not been tampered with. What I'm doing now is I'm going, and it happened fully automatically. What I'm doing now is I go to my school certificate, which I have prepared. And this is just a simple school certificate. And I'm now the class teacher, Frederick Halm. And what I'm doing now is I'm just supporting that or showing that this certificate is correct. So I'm signing it off. I have created it as a class teacher. And for that, I need to log into my wallet. So you see that I'm opening my wallet. This is the Fox. And I need to add my secret here to allow to unlock my private key to be able to cryptographically sign the page. This is what I'm doing. I'm logging in. And you see that the class teacher, Frederick Halm, here is the name again, has this cryptographic wallet here, which he can use to go now to the history of the page. And we can move the button somewhere else so it's easier to find, to sign this page. And what you see when we sign it here is I sign the following page verification hash. This is something we can automate and make much more nicer, right? But this is the first revision of the page. We are signing it. That's a cryptographic hash which is behind it. It's not important for the user. The important thing is that you are using a separate software which protects your identity to sign the page. We sign the page. You see that you get a short feedback about it. And now I go into the page to add my signature. This is a process which will be automated in the future. So right now I'm just doing it because we haven't automated it yet. But I want to show in the document that I have signed it, and I want to show the wallet I have signed it with. This is, like I said, a process which will be fully automated in the future. So what we have done is there was the creation of the page, and there was the signed signature of it. And you see that our detection has detected the page integrity is given. So I will change the perspective now. I will go over to the school director's view to access this page because he needs to sign off the school certificate before it's sent it out to the student. For that, I'm changing my browser. You see that I go over to my browser here, and I will go to the school certificate we have seen and load the page. And you see on the upper right corner, there was a short moment where it was automatically verifying the page. And it's already verified, so there's no need to check more. It's green. The teacher knows, the director knows, I can trust this page. If he really wants to see the details of it, he can verify the page manually again and see the progress. And he sees there is a wallet signature, which is the wallet signature of Frederick Halm. And you can compare those hashes in the end. It's like 54C2. These are the last 4 numbers, which are matching. So he knows, okay, this is indeed the signature of the class teacher. Very well. So he does the same thing. He says, okay, I trust this document. I've seen automatically verified. He doesn't need to spend a lot of time. He just goes into the history of the page and signs it himself. And it's the same process again. He needs to log in into his wallet to unlock his ability to sign the page. And then he can just sign it. We get a feedback that the page has been signed, and he goes back into the page. And again, this is a process which we will automate in the future to also add it to the readable part of the page that it was signed. So he just puts his signature in, something which we will automate in the future. So now this document has been signed by 2 parties, cryptographically provable. Some people know that as PGP signatures, but this is just a way how you use your handwriting, but in a way it cannot be faked easily. Now there is a very important aspect. The school teacher and also the director, they can't just like, they need to prepare those signatures and the school certificates for over 1,500 students. So it's really important that there is a way to timestamp them together. And this is what the director needs to do. He can easily set it up to be automated, but in this case, he's doing it manually. So what he's doing is he takes all the certificates which are generated in this domain, which could be 1,500 school certificates, and he generates something which is called the domain manifest, which is just packaging them up in one big package. And this is how it looks like. They are cryptographically meshed together. And they get just one root hash, just one fingerprint of this whole package. And he now can easily go and publish this to a blockchain by just going to the domain manifest publisher. And you will see that the Fox helps us again to send it now to the automatic witness network. This is how you timestamp 1,500 school certificates and make them, give them a proof of existence, which means it's around $10 at the moment for 1,500 school certificates. I mean, it's easy math to see that this is really cheap. So he did that, and you see the status changes from published to published, and he can click it to see the status on the blockchain to know that this has been published indeed. So this is already published. You see it's successfully published. And this is the fingerprint which we are looking for, which is a fingerprint of the whole package of this 1,500 school certificates. And that's it. I will show you as a last example that there is obviously the situation that something could go wrong, right? So what happens if a page is not working correctly? What I do is I will just import a page which has an error. So when we upload this page and now we click to it, you see on the upper right corner, it's automatically verifying again. And then it gets red. So it's really simple. You can judge after a second if this page is trustworthy or not. If you look into it, it says page integrity verification failed. And if we look at the details, you will see that a part of the history of the page is verified and another part isn't. So I just executed it, and you see that the revisions are totally fine until revision 5. And then there is revision 6, which breaks. So what we could do is we could revert back to revision 5, which is still trustworthy, and disregard everything which has been tampered with after the fact. Let's go back to our presentation. Let's do a short summary of what we have seen. we have shown in this short presentation a digital publishing workflow which creates verified data sets, which allow to establish peer-to-peer trust in a community or in an organization. This gives us a new reasoning method about what is true based on a social consensus over verified data points. It's a foundation to make decisions based on trustworthy data, and it's an ability for us to create a way to measure impact. It allows everybody to withhold the superpower of creating unforgeable receipts, which was held for many, 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 many years by only very big institutions. And it enables collaboration at scale because it can create data symmetry between people. This is a way for us all to freely contribute to an organization or in a different social setting while keeping personal accountability, because we know where the data comes from and data is fully accounted for. I'm coming to the end of the presentation, and it took me a little bit longer than I originally planned, but I hope we can use the last 30 minutes to discuss together what we have seen and maybe to clarify more things. If you want to contact me, my contact details and also the project update is posted on the bottom of the page, and you can just take those links to follow up. And now I'm super curious if you have come up with an idea where you could use it. I can tell you that we are working with academia very closely right now to reestablish trust for scientific contributions. We are looking into 2 pilots at the University in Washington and in the educational platform for open source education platform in Germany for the government. Now I'm curious.
All right, thank you, Tim. That taught me a lot. First, could you please stop screen sharing? Then we look into each other's eyes again. And yeah, let me just come back on Earth and back on our actual situation right now with all the non-trustworthy news that we have out here, non-trustworthy data that we have out here. I just did it myself. I did a LinkedIn post this morning to get perhaps some really short notice people that could join our conference, and then I tagged people and then forget about half of them, and then I edit my post and tag some new, right? And I could rewrite my whole post, and some people already liked me, right? And then I rewrite and write the complete nonsense or something out of context, and still the likes are still there. So people who like my post just trust me not to change the content too much. But basically, we would need this for just anything. For me, it would be interesting, yeah, of course, for example, Jürgen, who is in an extremely complex industry, or Elke, who's in research. Where are the points where we do need this? And my question to you, Tim, is where do we stand with this? How far are we from a standard? It was like an outlook in the future that I just saw, and I would like to see where the real world applications are right now, and who else is doing this.
Yeah. So to our knowledge, nobody else is doing it in this form. We have seen approaches of people claiming that they do verification protocols, but they just don't build prototypes which work. What we have done is we built first a prototype which works based on fully open source technologies, and then we started to speak about it. So we are in a phase which is launching the first pilots, proof of concepts in September, so next month. We are hardening the software for now for small scale pilots. We are looking for groups and people which might want to help us with it to accelerate the development. The standardization of the software, because there's a huge need for it, can only happen if we have built sufficient trust and accountability with sufficient pilots. So this is really heavily depending on how far do we get a rollout in the targeted industries. The targeted industries are education, revision-based journalism, and legislation and lawyers. So like everything which is related to contracts, which is related to legislation, which is related to documentation. We have access to the educational piloting sphere, so to say. We are still looking for stronger access to the legal space. And we have some prospects for the revision-based journalism. So the software, like I said, is fully open source, so you could go and use it in the same form I presented it today. It's a little bit painful to set up, so we are working on making it easier. So by the end of next month, you will have a much easier way to set it up on your own computer. But this is where we stand. We are in the hardening process of the first iteration of the software, and we take it from there.
It's hugely interesting. We will exchange ideas after this. We don't have so much time today, so yeah, I leave it give it to the audience here. Before you talk, of course, please unmute yourself, because you're all correctly muted, as you should, but you might have some input and questions as well. Elke.
Tim, nice to see you again. Great. So my first impression is I want to have that. And if I get it right, it's already there. A little bit complicated maybe, but it's there. So if I can start today if I want to.
Yeah, absolutely.
Great. I think it's very, very important, and it's used, and I'm especially thrilled about that it's used for services too. So, for example, our online tools service would be able to have it in this open source, right? Wonderful. I have another question. Who is paying you for all this, or is
Nobody.
this all voluntary, idealistic work?
So this happened by me having sufficient, like a little bit of runway, let's say it this way, to just work on it. I worked with a professor in a new university where we developed the concepts, and where I had the chance to get the theory right. And then I had the great pleasure of meeting a very amazing individual, a coder, who helped me to integrate it. I have learned 2 programming languages for doing the implementation work as well. It's how do you say, it's too important to wait for somebody. And I spoke with a couple of people, and the fastest iteration process you can do is by not outsourcing, but just doing it. So we just chose to do it. And if you look at the project page, we started at the 5th of April, and this is where we are now. So nobody paid us. We believe that the way how we would like to receive funds is by organizations which see markets which they want to claim. We see huge markets as secondary markets, but for a good spread of this technology, we need to establish a strong foundation. We are the organization which establishes this foundation and gives it away for free. Obviously, we will have opportunities on participation on second layer applications, and therefore business opportunities. But that's an individual thing everybody can do if they want to.
That would be like the main question for me, but let's cut that short because we have other questions. But really, what is the how do you make this a standard and make it fast, right? And this needs money, a lot of money, right? Even although you can do the pilot super fast, right? And reiterating and bootstrapping the beginning is great, and then you want to roll it out, and just the rolling out is like needs people, and people need money to go to the market and buy that food, right?
for accelerating it, we are interested in investments, but we need to, like, for example, we need to ask the question a little bit different. What are the costs we are saving you by using this technology? Not what is your revenue from it, right? So, and the cost you're saving is a lot of costs in verification processes which are flawed, where you put a lot of hours in for not getting good results. And it is for increasing, for example, being able to measure impact. So I would hope that we find investors which have an interest to deploy these technologies for the projects they're investing in. The NGOs which use this technology will become the first NGOs to have verified data. This is a totally different class of organization. They will have a totally different standing in any form of comparison.
Absolutely.
So this is what I'm hoping for.
Absolutely. So I give it to Abdurrahman. Just a hint in the end. If you look at it from a way like Plan A is doing, right? Plan A, Lubomila uses all her funds just to get out there, right? Because she needs to be well known. She needs to be become a standard, and that's what she's spending her money on. She's also saving money for everybody else, right? So this marketing aspect, that's me as well, right? So Abdurrahman, please.
So, thank you. I just have I mean, it might be a very stupid question, and I'm fine with it actually. But, I mean, since you're in the blockchain technology in depth, I mean, there's one use case that I cannot really grasp how it is easily implemented with the performance that is kind of close to what we have now in technology, which is retrieving the data in mass or querying the data, which is one of the biggest values of using traditional databases. And the question is always, is the additional level and layer of certification and security really worth having this massive performance drop? And obviously I'm not deeply technical into the blockchain world, but I was wondering if you have something to say about this.
Mm-hmm. Yes, so we have an a decrease of performance for sure, because we need to do a lot more steps, but you get a huge amount of value for it. So this means if you query verified data sets, they have not been manipulated or changed, but it really depends on the use case you're doing and the environment you're operating in. So we don't say that you should use it for everything. It is very valuable in certain use cases, and it's not that valuable in other use cases. And it's in the end the decision to make by the company which is using it. I think we should focus on the areas where it's most important, which is, for example, new scientific contributions, certification processes. And this area, it's not about processing, for example, a lot of sensory data. Mm-hmm. But what we could give you, for example, is to ensure that the sensory data you think you have is indeed coming from the sensor you think has generated it, because we are able to verify that. And this might be very valuable for you.
That's true. I mean, the thing is, the whole point of storing the certification is to be able to retrieve it at some point, right? And show the person, hey, I have the certificate and it's fine. And if you need to retrieve it from mountains of data, you're gonna suffer a little bit, and that's always baffling to me. Okay, how do we? I mean, in some cases, yes, you need this additional security layer and certification layer, which is fine, and you have the time. It's not like you're I don't know, doing a quick transaction. You can wait a few minutes until it's certified, and at some point this few minutes will be half a minute or whatever. Yeah, but in most cases, or at least the way blockchain is being promoted as the key to the future of storing and certifying data, it's
storing, certainly not. That's what we don't store it in a blockchain. It's really important to differentiate, right?
Okay, cool.
Data stays private in your personal knowledge container. Right. We are running out of time, and I don't want to take away from the other speaker. Is there any way, Kai, how we could continue the discussion with the people which are interested somewhere?
Yeah, well, what I would say is that the meaning of the conference, right, is to find the others. Right? So that's exactly what we're doing right now. I just sent you a message on LinkedIn, Tim, and because I could dive into some aspects of what you're about, and everybody else here in the room is. What we have set up is our small group that we already have, and I invite you you all to join Gita and to exchange in the groups there in the Slack space there. And the usual way is, hey, let's just connect on LinkedIn and then see which next meeting, next conference we can come together, or just for a virtual coffee. Lee, what's your take on that?
Sorry, yeah, I just came in the end, but I've listened in the past. I think it's a fascinating conversation. I threw in the link to the WhatsApp group. I think maybe that's a place where we can chat. It's a smaller location if anyone's comfortable with it, but would love to continue and maybe find maybe a second event that we can all jump in.
Good point. I see if I can paste it right here. Or do we already have it?
It's in the chat already.
It's in the chat
already. Okay.
Thanks
Good.
for sharing it. And
Good.
yeah,
Nice.
it was a pleasure meeting you all.